In this video, I will be talking about some of the display and analysis tools that are in the GUI. And so here I have already preloaded the truss example that I've shown a few times. In this particular one, this is the non-physics-based reconstruction. I chose this one because it has actual features in it of interest of things that we can try to measure. The other one was just a little bit too binary, even though it was a better reconstruction. There's more analysis you can do with this one. Okay, so let's talk about a few things. First of all, you can zoom in or out with these buttons. You can also use your scroll mouse to zoom in. You can pan either by dragging and moving your mouse on this image, or mostly in the thumbnail image. So this is the thumbnail image on the left, and the yellow square shows you what you're displaying, and you can click or drag this box around. The next thing is the slider here, and this slides you through the different slices. One thing is this is running slowly right now because it's going off of disk. So let's load the entire volume onto disk before we continue. So we'll go back to the beginning. If you go Preferences, oh, I guess it already is loaded. Let's say clear, load. So we'll load this into memory if it already isn't. And now the slider should go fast. Okay, so we can see all the slices. You can also go Y slices, shift from the side, or X slices. And you can also go oblique or 3D, and we'll discuss those later. The other thing you can do is if the image is noisy, you can click this slice thickness. I can say 3. And what this will do is that every time you see a slice, it'll be averaged 3 slices thick. So this still works with the slider, and it averages on the fly for you. And it'll apply to any of these views, whether it's Z, Y, or X, or even the projection data it'll work for. Okay, other things, if you right-click on the image, a box comes up, and you can save that image as a PNG, as a TIFF image, or as an SDT. Now, if it's a PNG image, it will save exactly what you're currently seeing. So if you zoom in to a particular area, let's say, and then we right-click, it will save exactly what you are seeing. And we'll save it as a PNG, which is good for a report. But if you just want to save the data in a screen, maybe you've done some averaging, but you want to export that in such a way that LTT or some future analysis software can look at it. You want to save it as a TIFF or an SDT because a PNG image is compressed. So you could select these. And if it's an SDT, it'll be in float. If it's a TIFF, it'll save it as a 16-bit unsigned integer, but it also carries in the TIFF header the slope and offset to convert it back to floating point, which will automatically be done if you're using LTT. When it loads a TIFF image, it'll look for that in the TIFF header and convert it to floating point. It's just a neat little trick to save some disk space. Let's see, other things. So histograms. So this is the histogram of the whole object. If we want the histogram of a particular region, we select this ROI, region of interest. And also the tooltip is reminding us that we can also turn this on by saying Control R. And this is the same box that we have used before, the region of interest. But now our histogram is updated to only capture information in the region. Now this region of interest does a few things. It not only does the histogram, but you can zoom to the region of interest. It does a lot of other things in it too. Anyway, let's zoom out a little bit. We're a little too close. Other things in this window are when it comes to your histogram, you can change the range at which it's displayed here. And then what's also here in all of these fields, this controls the display window of your object. So I can type in a new min and max. I can say the max is 0.1. It gets bright. I can also control this with brightness and contrast sliders. If I click these, they go to min and max sliders. I can set the min and the max as I want. The other option is if I click ROI, I can draw a box, okay? And then now it's a little complicated. It's in display controls. I can click auto, and it will auto scale my display to the min and max of that region. So for instance, if I put it here and clicked auto, it should look super bright, right? Or if I clicked it over the strut, it should look much darker, right? So, oh, and also that auto button, it'll tell you, you can also do it with Control A. And if you have no region selected, Control A sets you to the min and max of the entire image. So now that we're here and we're talking about the display, we can do a couple different color maps. Red and green and blue and cyan and magenta, copper, bone. 4 colors is just 4 numbers. The color map has the most depth in it, but it is linear with intensity, so it's a good one. And you can invert the color map here. Binary is a little bit different. This one's good for thresholding. So basically, if you want to know all values that are, let's say, between 0.1 and 0.2, it'll highlight those as white and everything else black. So that's just a thresholding tool. Okay. Let's see, what's next? Let's do lineouts. So here's the line profile tool. So to activate the line, I click this activate profile. And then I can click and draw a line. By the way, I didn't show this before. This happened with the region of interest tool. If you hover over any of the endpoints, I can click it and only drag that point, and it won't redraw the line. Or if I click outside, it'll make me redraw the line. So just to show you with the region of interest, when I click and drag, I can modify just one point at a time. I have to wait for that orange circle to display first, though. Okay, back to the lines. And as you can see, only one thing is activated at a time. You can only either draw a line or a square, or if none of them are activated, that's when you can click and draw, you can pan. But anyway, let's see what else we can do with these. So let's choose a little bit different slice, one where we see an apparent hole. So I'm going to drag, let's say I want to know the length of this. I can click and drag, and it says that it's 3.1 millimeters, and the line's at 135.17 degrees. So if I go to display controls, I can modify a lot of the stuff. If the font, if I don't want to see anything, I can say font size 0, it goes away. I'll put the 12 back. I can toggle the angle on and off. And then the line width, if you can't see it, I can, oh wait. So the line width here is for averaging. So if you change the line width here, when it plots the profile, it averages 3 pixels along this path. So let's move this up here so you can see what this does. When I change this to a 1, see, it got noisier. So you could do a lot of averaging here with lineouts. You can average multiple slices, you know, by doing slice width here. I guess I'm already doing that. Let's make that back to 1. And you can also do thickness of line here. Now other things we can do other measurements. So let's draw a line over something that looks like a void here. And if I click on feature calculator size here, then right now it's trying to estimate a valley. So it tries to figure out where's sort of the nominal position, calculates 50% down, and tells me that this red line's length is 0.19 millimeters. Now I can change that threshold. If I don't agree with it, let's say I think, so it's guessing it's 0.225. If I say no, it's 0.22, I can modify that. I can also modify the percent. So if I say 20%, it's only going to be this distance from the very bottom is only 20% of this full. And then it will also do peaks. So here it tried to find a peak in the middle. Maybe we want to do this. There you go. And it tried to find the 20%. What's the 50%? So it's the same thing as voids. And then the last one is MTF. It's not really appropriate here, but we could draw a line across. And I'll try to calculate an MTF. So here's the MTF. It's kind of it's not a very great MTF, but it's just something to play with. Another thing that you can do, we don't have any disks in this, but if you have an object that has a circle, then you could draw a square, like a region of interest, like this one here, around the circle to identify where it is. And then if you click MTF of disk in ROI, it'll calculate the sort of the ASTM standard MTF, and that's a very accurate MTF calculator. So next, let's talk about these. So these are little miscellaneous buttons. I can open up this one, and it'll just display a single image, and it displays it in the preview window. We have Arithmetic Dialogue Box. What this allows you to do, I'm going to dock this, allows you to do operations like, let's say I wanted to take Z slices and add them or subtract them. I can do that. I can do, this is binary operations, and I have unitary operations. I can multiply, shift it, scale it, exponential, FFT, shift it, a bunch of different things. So these are just little mathematical operations that you can do to your various images here. The next section is the rendering, so let's talk about that. So the way you activate that is you click on 3D. And by the way, if the image isn't already loaded into memory, it will require that you can fit the entire volume into memory. Okay, so here's what I have, but so far, so you see I docked the display controls window. Now it's behind the workflow window. This is an isosurface rendering. I can change the threshold here. This is a better threshold. I'm going to do the Control A, or the auto button, so we get a better display. And let's rotate this around. So you can rotate with the slider. Also in newer versions of the GUI, you gotta turn off the, if you turn off the region of interest in the line, you can click and drag it. Anyway, so this is an isosurface. You can also do a density display. So now this gives you just like the slice display, but in 3D. Or you can do a MIP. MIP is maximum intensity projection. It's not very good for this particular sample. But let's see what we can do with these. So one thing that we can do is, oh, and you can also tilt it. You can give it an angle this way, and I can get more of a 3D view. I can crop this volume. So I move in these, and you see it cut away from the side there. I can cut away on that side. Now this is one type of cutaway. If I click corner, it'll do a corner cut. So now here you can see the cut. Maybe I need to be a little more aggressive for you to notice this. So I can cut this away. So that's a corner cut there, and this is just an isolation. So I can move these sliders around to cut this thing and look at specific parts of it. And this works whether it's density or isosurface renderings. You can do these. Okay, so that's the rendering. So now the oblique slicing is if you want a slice that's not exactly aligned to one of these coordinates. So I can enter the azimuthal and polar angle here, but another way that I can do this is, let's say I wanted to get a slice that was along this boundary here. Then I'll type Control L for line out, which I could have also done by clicking Activate Profile here. And then I draw a line along that surface. Okay. And I click Set from Line Out and Oblique Slicing. And now it will set these so that when I click oblique, it will go right on that plane. And you can see here that we are pretty parallel to it. You can see the plane quickly disappears. So I can view it at any oblique slice that I want. Okay, other things like the profile plot, I can also save those to disk. Oh, MTF is still on. So if I also right click over this plot, I can do a lot of things here. A lot of these options, but the one I'll show here is export. I can export it as an image file. I can also export it as a CSV, so this will export the data for you. Any of these options here, and it will save the data. And you could do that with any plot that you like. So remember, you can right click plots and images alike, and they will both offer you different ways to save the data. So I think that's it for today of the display tools. I'll put further videos in the future.